Hi everyone, we are going to see Laplace transform problems in this video presentation. Right. What is the formula for Laplace transform? Laplace transform of x of t is equal to x of s, which is nothing but minus infinity to infinity x of t into e power minus st into dt. Right. Now let us look into the first question. We are supposed to find out the Laplace transform of a impulse function. Okay. Right. Now what is del of t? Del of t is equal to 1, for t is equal to 0 and it is equal to 0 otherwise. Right. We all know it. Right. Now what I am going to do, I am going to substitute instead of x of t in this formula, substitute del of t. So 0 to infinity del of t into e power minus st into dt. Correct. Now this is what I told you here. Del of t is equal to 1, for t is equal to 0 and 0 for t not equal to 0. So which means that at t is equal to 0, del of t is 1. So substitute that. At t is equal to 0, del of t is 1. So e power minus s of 0. E power anything, e power 0 is going to be equal to 1. So Laplace transform of impulse signal is going to be 1. Okay. Right. Now let us move on to the second problem. What is second problem? X of t is equal to u of t. And you all know what is u of t, right? What is u of t? U of t is equal to 1 for t greater than or equal to 0 and it is equal to 0 for t lesser than 0. Right? You all know how unit step signal will look like. Yes or not, students? Right? So it is going to be like this, right? Yes or not? For t greater than 0, your unit step signal is going to be like this, right? Now let us proceed on with the problem, right? So integral 0 to infinity u of 2 u e power minus st into dt, right? Now what happens? U of t is equal to 1, right? So 0 to infinity e power minus st into dt, right? Actually, the limits can be from minus infinity to infinity. Only after you substitute u of t to be 1 is applying this formula, it changes to 0 to infinity. Correct? Because u of t is equal to 1 for t greater than 0. That is why the limit of the integration changes to 0 to infinity. Right now, start integrating e power minus st into dt. When I integrate this, it is going to be e power minus st by minus s. Correct? So e power minus st by minus s. Apply the limits 0 to infinity, right? And when I apply the upper limit, it is e power minus infinity minus e power minus 0. You all know e power minus infinity is going to be 0, right? And e power minus 0 is 1, right? And the lower limit you have a minus and this minus it's going to become positive. Is that clear? So what you need to remember is e power minus infinity is 0 and e power 0 is going to be 1. So you get this answer for step signal. Correct. Next, third problem. We are going to find out the Laplace transform of x of t is equal to a into u of t. Now take the Laplace transform, minus infinity to infinity. Instead of x of t, you are going to substitute a into u of t, e power minus st into dt. And you all know what is u of t. You know u of t is a step signal. So which means that u of t is equal to 1 for t greater than 0. So what happens to your integral limits? Your integral limits changes from 0 to infinity because you have u of t to be 1 for t greater than 0. So a into e power minus st. Now take this constant a, integrate it, apply the limit. See here, I have clearly shown you e power minus infinity is 0 and e power minus 0 is 1. So what is the answer? Right? So this minus and minus will become a plus and you have x of s is equal to a by s. Right now, what is the pole? S is equal to 0. Or what is the region of convergence? Region of convergence is to the right of sigma is equal to 0. What is S? You all know sigma plus j omega, right? So sigma is equal to 0, right? So region of convergence is to the right of sigma is equal to 0. Correct. Next. Now we are going to find out the Laplace transform of a constant. So Laplace transform of 1. And we are going to prove that the answer is 1 by s. Right, you all know the Laplace transform formula. What is the Laplace transform formula? Laplace transform of formula is going to be minus infinity into infinity x of t into e power minus st into dt. And what is x of t here? X of t is 1, right? So 0 to infinity 1 into e power minus st into dt, right? Now when I apply the limits, e power minus st by minus s with the limit 0 to infinity, and you all know when I apply the upper limit and lower limit, I am going to get it as 1 by s. So Laplace transform of 1 is nothing but equal to 1 by s. And the condition is for s greater than 0. Right, now we are going to find out the Laplace transform of e power at. Right, so what is x of t? X of t is e power at. We are going to find out the Laplace transform of e power at. Now as usual, write down the Laplace transform formula. Right, Laplace transform of e power at is nothing but 0 to infinity x of t. What is x of t? E power at into u of t, right? That is why it has changed to 0 to infinity. So e power at, e power minus st into dt, right? Now what is the next step? Take minus common, so e power minus of s minus a into dt. Now integrate it, apply the upper limit and lower limit. So what do you get? I get it as 1 by s minus a. Here also the same story. E power minus infinity is going to be 0 and e power minus 0 is 1. So minus 1 by minus of s minus a. That minus and minus will become plus. So I get it as 1 by s minus a. Right? And what is the pole? S is equal to a. What is the region of convergence? S greater than a or sigma greater than a. Right? The next problem, let us see. Right, here what is the problem? Determine the Laplace transform of x of t is equal to t into u of t. Whenever you have u of t, your Laplace transform formula from minus infinity to infinity changes to 0 to infinity, because you all know u of t is equal to 1 for t greater than 0. Correct? Now, now what's the input? X of t is nothing but t into u of t. So t into u of t I have submitted, and I have substituted, and I am replacing u of t by 1. Then the integral limits will change from 0 to infinity. I get this. Now what formula I have to apply here? I have to apply integral u dv. What is integral u dv? uv minus integral v du. Now what is that? I have taken dv here. dv is nothing but e power minus st into dt. So integral dv is going to be v. So integral of e power minus st into dt is going to be e power minus st by s. Now what formula I have to apply? uv minus integral v du. So that is what is written here. U is t, correct? Yes or not? U is t, and what is v? Right? v. So v we have found out, e power minus st by minus s. So that is what is given here. Minus integral v du. What is v? E power minus st by minus s. And what is du? It is dt, right? So you here, though it's not shown, u is equal to t, du is equal to dt, correct? So that is what is written here. Now apply the limits, do the integration and apply the limits. So t, what is t? You all know, it's infinity and 0. So when I apply t to be infinity, right, infinity, e power minus infinity is going to be 0. So this term will become 0. Second term, anything multiplied by 0 is going to be 0. So this term vanishes. First term vanishes. What is second term I have? 1 by s into e power minus st by minus s. Right? Now once again apply the limits. It will be e power minus infinity minus e power 0, which means that e power minus infinity is 0 and e power 0 is going to be 1. Right? So what will I have? Minus and minus will become plus. I have it as 1 by s square. And what is the region of convergence? Region of convergence is to the right of sigma is equal to a. Here also s is there. S is equal to 0 or sigma plus j omega equal to 0. From there only you get your region of convergence. So sigma, region of convergence is for sigma greater than 0. Correct? Next. Now let us look into the next problem. X of t is equal to e power minus a into mod t. And you all know what is mod t, which includes both positive and negative values of t. Now look into the formula of Laplace transform. minus infinity to infinity x of t into e power minus st into dt. Right, now what I'm going to do is I'm going to change this integral limit, right? What is the integral limit here? Minus infinity to infinity. I'm going to change it as 0 to infinity plus minus infinity to 0. That is, you start from, actually this term should come here and this term should come here, right? You start from minus infinity to 0, then from 0 to infinity. This is the right hand side and this is the left hand side, right? For t lesser than 0. Now this is going to be for t lesser than 0. What is this term? What is this term? T greater than 0. Right. Now start applying. When I apply it, that is, you split the terms. Here also e power at into e power minus st into dt. That is, for minus infinity to 0, you get it here. You get this value here. Now club the terms. So when I club the terms, e power minus of s plus a into dt plus integral minus infinity to 0 e power minus s plus a into dt. Right. Now apply the limits. Right. So what I get, 1 by s plus a plus 1 by minus s plus a. If I take this minus here, it will be 1 by s plus a minus of s minus a, right, which is nothing but equal to minus 2a by s square minus a square. Correct? Next problem. Let us go on to the next problem. What is the next problem? Determine the Laplace transform of the following conditions. Continuous time signal, right? X of t is equal to a sin omega t into u of t, right? Now, if I have u of t, what is it? Anywhere if I have u of t, it is a right-sided sequence. So, what will your integral limits change? Your integral limits will change from 0 to infinity. A sin omega t, t into e power minus dt into dt. Correct. Now, what I do is I integrate this, right? I take a common, and you all know what is sine theta, e power j theta minus e power minus j theta by 2j, right? Now take 2j also as common. Now start doing the integration, right? When I do the integration and look into this final step, 1 by s minus j omega minus 1 by s plus j omega. So in that case here, you can do a cross multiply and you get this answer, right? Or x of s is nothing but what I get, a by 2j into 2j omega by s square plus a square. Here that 2 will get cancelled, j and j will get cancelled. It is going to be a omega by s square plus omega square. Correct? Next. The next problem is going to be find out the Laplace transform of e power minus at into sin omega t. And you all know what is sin omega t? E power j omega minus e power minus j omega by 2j. Correct? Now what I am going to do is apply. So what will I write? This is going to be 1 by 2j. This 2j I am taking it out. So what I'll have, integral 0 to infinity e power minus at into e power sigma into e power minus st into dt. That's the first term. What about the second term? 0 to infinity, right? E power minus at into e power j omega divide into e power minus st into dt. I have taken this 2j as common. Now do the normal integration, and what is the answer I get? Here I have to take in this step I am going to take an LCM and I get the answer to be that is Laplace transform of e power minus at into sin x of t is nothing but what you get. You get it as omega by s plus a the whole square plus omega square. Right. Yeah, this is the last problem what we are going to see. X of t is equal to cos omega naught t. So formula for cos omega naught t is e power j omega naught t plus e power minus j omega naught t by 2. Now apply this x of t value in the Laplace transform formula. So I get it as 0 to infinity e power j omega t plus e power minus j omega t by 2 into e power minus st into dt. Now split the terms. Yes or not? First term and second term. Do the integration. and I get the answer as 1 by 2 into 2s by s square plus omega square. This 2 and 2 gets cancelled. So what is the answer I get? Laplace transform of cos omega naught t is s by s square plus omega square. Is that clear? Right. Thank you, students.